So, good morning, everybody. I see that there's still some people coming on and joining the webinar. So, let's maybe wait for another minute before we get started. And to those of you already in here, thanks for joining and thanks for being on time. We'll be starting the webinar soon then, and I'll tell you a bit about how INEOS Styrolution does sustainability. So, don't go away. We'll be kicking it off in a minute or so. Good. Then I would say we kick off the webinar. Good morning, everybody, again. My name is Johannes Musseleck. I'm Head of Global Sustainability at INEOS Styrolution, and I have the pleasure to talk to you today about performance up, footprint down, how INEOS Styrolution does sustainability. So this is kind of an overview presentation that I will be given that looks at all the aspects of sustainability, that looks at, what we mean when we refer to performance up and footprint down, which stands for, a lower footprint, a lower carbon footprint as well, at the same performance level that you are used to and that you are enjoying with our conventional solutions. And I want to show you today how we plan to make this happen. This webinar today is kind of the starting point to a webinar day, or actually to two webinar days that we have in store for you. And before we get started with today's program, let me give you a quick quick overview at what else we're going to present to you today and on Thursday. And you're obviously invited to also join the other webinars. Let me start with today's program. As you can see in today's agenda, we are now in that first webinar that gives the introduction to sustainability in our program. In a bit less than an hour, there will be Christian Ruthardt talking about recycling technologies and going into a bit of a deep dive on the recycling technologies. I will give you a high-level overview here right now. And then Christian will take it away in a very interesting webinar on the technologies. This afternoon, starting at 1 p.m. CET, there will be Stefan Schwind and Manuela Kasut that will talk about our offering in the area of modifiers. Very exciting stuff and very new stuff there. Before we will then move into more of an industry type of view. At 2 p.m. this afternoon with a presentation on the household electronics industry. At 3 p.m. we will be looking at the building and construction industries, and we'll finish the day off at 4 p.m. With a look at the packaging industry, which is going to be also a very exciting webinar presented by Michael Schuster and Jana Klausdorf, since packaging is one of the big sustainability challenges that we're all facing, as you know. So a lot of interesting stuff today, and please feel free to register for any of those webinars. Also, in 2 days from now, on Thursday, we have another bunch of webinars coming up. You can see me again if you like it so much this morning. It's going to be the same presentation that I will show you today. But then at 10:30, Marcela Viegas and Frank Eisenträger, our product directors, will be talking about our product portfolio. That's going to be a very, very interesting presentation because it looks at all aspects of our portfolio, which products we're having in our eco product portfolio, which carbon footprints they have, etc., etc. So a lot of information to be got there at 10:30 on Thursday. And in the afternoon, again, we were looking at things from an industry-specific view with our offering for the automotive industry at 2 p.m. by Frank and Eric. Before at 3 p.m. we will be looking at the healthcare industry that Albert will tell you everything about this. And finally, on Thursday at 4 p.m., Ken McIntosh and Peter Rath will talk about the toy, sports, and leisure industry and the particular eco solutions for those particular industries. So, a lot that we are having in store here. Again, please feel free and feel invited to also join those webinars if you want to get a deep dive into any of those particular topics. Because, well, what I will be trying to do right now is to give you a bit of a high-level overview of what our sustainability program and our sustainability efforts, which we subsumize under the term performance up and footprint down, which I will explain to you in a minute. After that short presentation, there will be a question and answer opportunity. So please feel free throughout the presentation to type your questions into the chat, and I will try to do my best to answer them after presenting the slides. So that's your opportunity to ask if there's anything unclear or if you want to know anything in particular. Good. Performance up, footprint down. What does it mean, and why is this our key positioning and our key claim of our sustainability strategy? Well, first of all, because we are convinced that if we really want to advance sustainability quickly and successfully, we need to make the switch to sustainable solutions as easy as possible. What does that mean? That means that we want to create drop-in sustainability or sustainable styrenic solutions. And that means we want to have the same high product performance and product properties that are on par with conventional products. And we want to have solutions for all applications that are using styrenics today in a way that they can be used as a drop-in, so without having to adjust a lot on your end. The footprint down part, however, is that at the same time we try to, eliminate negative externalities of products and operations and amplify these positive effects that the products can be having or have. So we are focused on eliminating bad handling of plastics waste, recycling plastics into new products, and we want to continue to offer safe products and reduce our carbon footprint ultimately to zero. And I will show you in detail how we want to make this happen. And what our game plan is in order to get to this point. The starting point for all of this is that we want to tackle, two mounting challenges in the industry. The first is the prevention of littering and waste, and the second is the reduction of carbon emissions. We really care about these challenges. Not only we care at INEOS Styrolution, but also our owners care, our management does, and everyone working here does. And that's why we want to tackle them. And our sustainability roadmap is built on this. We are developing solutions together with our customers, with partners along the value chain that can ultimately make this happen. And we need those partners and we need these corporations because we believe that no one can do this alone. It's a huge challenge that we're all facing, that we're facing as an industry, that we're facing as a society. Therefore, a lot of cooperation is needed here, and we are happy to work with you and to work with the whole value chain and even build a completely new value chain in order to really reduce littering and waste and really drive down carbon emissions. What does our future product portfolio look like if we come from that starting point of reducing carbon emissions and littering and waste? We have developed solutions for that challenge, and one of the biggest and most interesting areas is that we will be talking today about recycling and bio-attributed materials. Recycled products that are products that contain recycled feedstock, and bio-attributed products that are products that contain contain renewable content that we are attributing via a mass balance approach. Target is, and that's the key point about the performance up part, that we want to have the same performance as conventional products. so that you don't have to worry about, can I use this for these challenging applications? Can I use this from an aspect of mechanical properties? Can I use this in food contact whatsoever? Our challenge and our target is that we really come up with the same performance. And that offering of recycled and bioattributed materials with high performance, we subsumized in the brand of INEOS Styrolution Eco. So when you see an INEOS Styrolution Eco product, this is where our sustainable products are. This is a drop-in solution, and that makes it easy for you to use them. So that's our portfolio of products with recycled content, with bioattributed content, that is ultimately having a lower CO2 footprint as well. Now, that being said, let's have a look at our sustainability strategy and at the key pillars and what we want to ultimately achieve. We subsumize this in three main buckets or three main pillars that kind of show our ambition with respect to sustainability. The first one is quite simply that we want to save 1 million tons of CO2 equivalents in 2030. That is scope 1 and 2 emissions only compared to our baseline 2019. As you can imagine, and I will go into more details in a minute, this means that we will be needing to do a lot of changes to our operations and to how we produce materials. And that means that we will have to do significant investments, but we believe that this is what we should do and this is what we need to do. So this is carbon emissions down. At the same time, we want to increase recycling and reduce waste by selling 500 kilotons of eco products in 2030. And the final pillar is that we want to guarantee 100% of regulatory compliance for both our virgin materials as also our eco portfolio. And that's, I think, extremely important that we don't lose that regulatory aspect out of sight, because we are talking about new products coming from a new stream also of raw materials. So this is a very, very interesting area that we're looking at. And on top of this, and that's what you see on the left-hand side, we want to achieve net zero emissions by 2050. So it's not only a 2030 target that we're having, we also look further to 2050, where we really want to be net zero. So a huge amount of work in front of us. And what I will do right now in this presentation is to run you through those three main areas. So how do we want to save 1 million tons of CO2? How do we want to sell 500 kilotons of eco products in 2030? And how do we want to guarantee regulatory compliance? Let's start with the first one. And the first one is our pathway to a low carbon economy. As you can see, we have 6 different approaches on how we want to reduce the carbon footprint of our operations and the carbon footprint of our products. As you know, we've already launched a portfolio of products with the circular or renewable feedstock. That's the Styrolution Eco portfolio. And that is important because that's kind of the first pathway on our quest to reduce our carbon emissions. Because typically these eco products come with a significantly lower CO2 footprint than conventional products. And that applies both for bio-attributed materials as also for recycling materials. Now we'll go into a bit more detail when I talk about the products in a minute. The second step is that we are trying to switch feedstock. And that particularly means that we want to move to more renewable materials. And I talked about recycling and renewable already. And as you may or may not know, particularly renewable feedstock has a significantly better CO2 footprint, even better than recycled materials. So that is a very attractive part of the offering. Third part, and that is now more on the side of our operations, is that we want to change the fuel that we're using in the way of a move towards clean energy. We have already started a lot of activities in this area, particularly in Europe. And we're happy to say that we've already switched our sites in Germany, and in Belgium to green power. So we are using 100% of green electricity in those installations, which is the lion's share of our production sites in Europe. We want to extend this program also into other regions of the world, so not only Europe. We're working on this in the Americas. We're working on this in our sites in Asia, because we believe that this is absolutely important if we really want to be serious about reducing the CO2 footprint of our installations. And then finally, and that is probably maybe even the most difficult area of it, we're investing into optimizing our processes and make them more energy efficient. And I will talk about this program in a minute. It's clear that this is the most long-term effort of all of these, and this is the most costly effort of all of these. But we've built a portfolio of measures that we are now implementing, and that we have already started rolling out, which can bring us to that 1 million tons CO2 saving in 2030. As you can see, there's also two other areas that are not in green because we're not working on them as of yet, but that may be very important for the pathway from 2030 to 2050 towards net zero. That is that we also looking into carbon capture and storage together with other businesses in INEOS, and also into carbon offsetting. So a huge program in front of us. How does this? How do we break this down, and where do we stand today? This is the overview on kind of our greenhouse gas roadmap, starting in 2019 with our baseline and going all the way to 2030 and then ultimately 2050. As you can see, we have already mapped out how we want our greenhouse gas footprint to develop until 2030. And this is backed by activities. So we've already started the implementation. We have some fast-track activities that are already delivering results. Our scope 1 and 2 emissions in 2021 are already 10% below those in 2019, which is very encouraging because it shows that we are on the right track here. If you look at that curve that I'm showing you here, then it goes down from 2019 to 2030 with a small uptick that you maybe have recognized here. That is not because we are reversing some activities here. This is because we will be adding new capacities in Ningbo and in Bayport for new plants that we are building in China and in the US. Now, this agenda that is behind it is built out of concrete and feasible activities. Right? So we have a portfolio of measures here that have a high technological readiness level that we have put together into a clear roadmap with a clear plan on when to implement what. And that makes us so confident that this is a realistic agenda. So we did not only throw out a figure and say, hey, we're talking about 1 million tons of CO2 emissions in 2030 that we want to save. There is a very clear approach behind it. And just to give you a bit of a reference, 1 million tons of CO2 is roughly 45% of our total scope 1 and 2 emissions. So this is not a small chunk. This is a massive change in how we work and in how we produce. And then ultimately, we want to achieve net zero in 2050. And also here, we already have a portfolio of reduction options that, are not as concrete as those until 2030, to be honest. But that makes us very positive that the goal of net zero in 2050 can be achieved. So that's our agenda in one slide with respect to our development on our greenhouse gas footprint. Now, let's move on to the second of the main pillars that I promised you, and that would be recycling and the recycling technologies. And again, as a reminder, there will be a webinar coming up in, in 40 minutes or so from now, in which you can learn a lot more about the recycling technologies. So I'll give you a bit of a high-level breakdown here of what we are doing. You see on a chart right now, it's kind of our traditional value chain. So we use fossil feedstock, then produce monomers, polymers. They are being used in various industries, and at some point in time, they reach their end of life. This is our starting point for the activities. And it's clear that we want to avoid landfill and incineration in the future. We want to create a circular economy. And here's a couple of circles that I can offer to you. And that reflects our various recycling opportunities that we are using or that we are looking at. Now, you may be asking, why not simply focus on one and do a one-fits-all? Because we believe that it makes a lot of sense to use some of those in parallel because they're complementary. And I will explain this to you right now once we run through this bit more complicated slide. If we look at these circles, then there is the first two technologies, which would be mechanical recycling and dissolution, that bring us back to the polymers straight. So there is not a lot of chemistry involved here. This is a very straightforward approach of going from polymer recycling back to the polymer. This is the closest loop because these products remain on the polymer level. And this is a very efficient circle because it's a short circle, if you will. It comes with a high technology readiness and probably the best CO2 footprint of all of those solutions here. The downside of it is that it's probably less flexible than others, both on the feedstock input side as well as on the output side, because you can only go from one polymer to the same polymer again. Right? But it is a very efficient pathway. The next one that we are working on is depolymerization, and that works for polystyrene because polystyrene is unique because not all of the polymers can do this. You can take polystyrene and break it down to the monomer, back to styrene. And that's wonderful because that gives you a lot of opportunities. The styrene you can use in all kinds of products again, in all kinds of styrenics products, with the same performance as conventional products, and that includes also food contact. So that's why we believe it's very important to also have depolymerization as an approach in our portfolio. And then finally, there are mixed waste technologies. That's pyrolysis or gasification, where you go back to chemical feedstock. Typically, these go back even into a steam cracker. So you really go down into hardcore chemistry. The huge advantage of those is that they offer the biggest flexibility. It already says mixed waste, so you can put various waste inputs in there. And because you really go down to basic chemicals, you can use it for all kinds of applications. Now, you will realize two things when you look at this. First, there's an enormous number of different recycling technologies, and that's one of the advantages of styrenics, and particularly also of polystyrene, that you can apply basically all recycling technologies that are available in the market. And not many, well, maybe better say very, very few products can do this. And the second point is that there is a kind of trade-off. So if you move from the bottom to the top of the slide, you will gain more flexibility, but you also create a larger circle, which represents a more complicated process. We see that the more down here you are, the better the CO2 footprint is. We believe that ultimately all of those technologies will result in products with a better CO2 footprint than a conventional product. But this effect is more pronounced the closer to the center of the circle you are. And as I hopefully was able to show you, these are complementary. Different inputs of waste, different usages for the output, and so on, are a very, very good reason why it makes sense to look at all of them, and why it is so great that styrenics are able to deliver that many recycling capabilities and possibilities. So finally, what we can do is that we change the feedstock instead of recycling and feed in renewable feedstock. Maybe at a very early stage that we can then attribute throughout the process. In summary, Why are styrenics so great for recycling? Because they have an unequaled recycling performance. First of all, in the collection of, for example, household waste, they have a very low contamination uptake. So if you get styrenics out of the waste mix, it's probably cleaner than most of the other polymers would be. Then it can be easily sorted in the waste stream. Existing technologies make it very easy sortable, probably easier than most other polymers. I mentioned this on the previous slide. All recycling methods can be applied. That's great. And as a result, you get to products that have the conventional product levels and avoid downcycling. And that is absolutely important. We talk about performance up, footprint down, and that means we are not talking about downcycling. We're talking about great performance of the products. And styrenics are perfectly equipped with this. And footprint down means that all of this will result in a lower CO2 footprint. So, what is possible? We are talking about even food contact to food contact recycling, which kind of is the holy grail in recycling. And also, we talk, particularly in polystyrene, of multiple mechanical recycling cycles that are possible. So you may know from other products that once you recycle them mechanically, with every cycle that you do, the product degrades and the quality of the products goes down. There we are in a very strong position with styrenics and particularly with polystyrene because it keeps the properties probably better than most other products. And all of these advantages make us confident that we will be able to really drive up and scale up the production of those products. We see a lot of demand for these products. Now the challenge is to scale up as quickly as possible and make them available in the market. And the final area and the final pillar that I want to share with you today is the compliance, the regulatory compliance of our product portfolio. And as you know, this is one of the areas that we're really dedicated to, no matter if we talk about an eco product or conventional product, because we always ensure 100% compliance of our full product portfolio. Now, what is new is that we want to do the same also for the eco product portfolio. And that means that we need to really drive up our efforts here because if you just look at feedstock, we need to review the feedstock with much more diligence than we would for conventional feedstock, which is well known and where the processes are well known. So we are looking at every feedstock source and take tremendous efforts to improve them. And as a result, this has required a significant step up in our regulatory resources that we are putting in, but also in testing and at the number of substances that we are reviewing. And in parallel to this, we are also launching investments on our sides because we really want to make sure that we maintain the best possible standards here. So a significant step up in all areas. And you will profit from this because that will mean that even for recycled or bioattributed product, you kind of get the same regulatory guarantees that you are getting or that you are used to from conventional products. Now, all of this is great and is also a very challenging pathway. But there's also some things that need to happen that we in order to be enabled to go this pathway. That's what I try to subsumize on this slide. What do we actually need? And it starts on the CO2 footprint side with green power infrastructure. I laid out that switching to green power is on our agenda and will become important as we go along. But the infrastructure needs to be there. We're not alone in this. Many companies are switching over to green power. Many households are. And the infrastructure needs to be there. Otherwise, that is simply not going to be possible. And that is not only the production infrastructure, but also when it comes to the networks. On the recycling side, we are in a very special situation. Outsiders probably won't understand this. But when we talk about recycling, we have recognized that sufficient waste is the bottleneck for many recycling projects. That sounds a bit bizarre because the starting point of a lot of the recycling efforts has always been there's so much waste everywhere and so on. But that waste ultimately needs to be available for recycling. So, particularly collection systems must come into place, and well, governments need to make sure that the whole waste feedstock structure, the waste management structure is in place that could lead to recycling. We're happy to do the rest then, but we can only recycle waste that is there, that is not going into a landfill or is not going into incineration. And that's what we try to work on with a lot of partners, but where we also need support in order to make that waste available. And in parallel to this, we need acceptance of all of these recycling technologies, particularly also of advanced or chemical recycling, because that will play an important role. Not only on styrenics, maybe even more so for other polymers, but advanced chemical recycling and the mass balance schemes behind it are required in order to enable companies to scale up and drive up the recycling efforts and to ultimately come to a very powerful recycling landscape. And then finally, we need reliable frameworks, reliable regulatory frameworks. There's a lot of projects that we work on, and well, if the regulatory environment consists of moving targets, it's very difficult for us. So we need to have clarity. What do we need to achieve in order to be able to put a particular recycled product into a particular application? Once we have this, we will get there, and we will put all efforts in to make it happen. But ultimately, we need that clarity, and we need to have a clear framework here. And if that is all there, then we really believe that our large approach and our large ambition can be made a reality, that everything is put into place in order to really make a significant positive contribution to our industry and also in a way to society, to build that recycling value chain all the way down to your business and to your customers' businesses. So then we can really save that 1,000,000 ton of CO2, then we can really sell 500 T of eco products and guarantee 100% of regulatory compliance in 2030. Again, all of this can only happen if we work on this together. So this is a challenge for the whole value chain. Not only us, also upstream recyclers, suppliers, customers, brand owners, and many, many more. It's a huge challenge that we all look at and that we are very dedicated. Everyone at INEOS Styrolution is. It's close to our heart, and you can rely on us. That's probably the final message that I want to give to you. Thanks for listening. Thanks for taking the time. And what I would suggest we do right now is that we take a look at the questions that you may be having on performance up and footprint down. So if there's any questions that you have, feel free to put them into the chat, and I will try my best to answer them right now. So feel free to type your questions, take your time. In the meantime, I've again put up the agenda of the upcoming webinars. Again, please take this as an invitation to also join those. Exciting stuff coming up, particularly when it comes to recycling technologies. I gave you the overview today, and Christian will in 20 minutes take it away then. I see that someone is trying to type questions. Please feel free to do so. Um, I'll stay put here and wait for what you may be asking. Good. So first questions are coming in. I'll tackle them in a random order. Um, yeah, net zero emissions. The basis relation for net zero emissions would be scope 1 and 2 emissions in 2050. Well, since we're talking net zero, it doesn't really matter if what the basis year there is. So either we drive the well direct emissions down to zero already, or and that's what I laid out when we looked at the various or the 6 approaches for reducing CO2 emissions, or we're looking at well using the carbon that's coming out of the production processes by carbon capture, utilization, or storage, or whatsoever. And the total will then be looking at, would then be zero. That's the target of it. What is dissolution? Yeah, dissolution is a solvent-based way of recycling. It's in a way similar to mechanical recycling, but it uses solvents in order to achieve a very particular cleaning and to make it uh, available for broader areas of feedstock. So kind of this material. Um, which would then still remain in a polymer form, maybe with a somewhat shorter chain length. Are you going to help organizing recycling streams for styrenics, as all materials will be banned in France from 2025 if no stream? That's a great question there. Yes, we are working on various angles in order to make sure that styrenics will be available for us. And this, towards the end of the presentation, that this is a huge challenge. We are working on this in many countries, and including France, obviously. So yes, we have activities in place in France as well, in order to make styrenics waste available for recycling and to organize the waste stream. Now, what is the challenge here? If you want to recycle, you need to sort the waste at some point in time, right? Styrenics have the advantage that they can be sorted, but someone needs to do it. And in the past, there was simply no need to sort out, for example, polystyrene out of the waste stream. And that is the switch that, from a waste value chain perspective, if you will, we need to do right now. We need to come to the point that styrenics and other polymers are sorted out. And that's a change that the whole value chain needs to do. We see very encouraging signs there from kind of all angles of the industry. Also because we see the demand. And at the end of the day, if there is demand for styrenics waste, and there certainly is, because we need it for recycling, you will need it for your products, then that will also lead, and I'm very confident here, to more activities on the front end, so on the well, in that waste value chain. And again, we're talking to a lot of partners there in many countries in order to make this happen. Good. So those were the 3 questions that I saw. Guess I've answered them all. And if that's the case, I will say I would be closing down the webinar here. Please feel free to reach out to us in case you have any additional questions, or again, have a look at the other webinars that are coming up here. Let me, at the end of the session, thank you a lot for joining and for your interest in our sustainability agenda. We'll try to make this happen together with you, take it from there then. So, thanks again today, and if there's any questions, please feel free to reach out to us, and have a great day and have fun with the other webinars. Thank you.
Driving success together.